Being able to use our hands is critical to survival, especially in cold environments. How much does our manual function get impaired when our hands are cold and wet? In today's episode, we'll explore a study that tests the separate and combined effects of cold versus moisture on manual function. How much impairment happens with cold and wet hands, and is having wet hands as bad as having cold hands? Our hands and our ability for fine manual dexterity is critical to our evolution and daily activities as a species. Think of the fine finger dexterity that is required for sewing and cross-stitching, playing piano, or performing surgery. In cold environments, however, the hands can lose heat extremely quickly because of the large surface area and also because of reduced blood flow, and this can greatly reduce manual function and become a threat to survival. This can be something as simple as not being able to hold and grip your jacket zipper to close up your winter parka, causing you to lose heat and risk hypothermia. And oftentimes, your hands aren't only cold, but they may also be wet. So an obvious question becomes, how much of your manual dexterity is impaired when your hands are cold and wet? A secondary question is whether that impairment comes from your hands being cold or from them being wet. To study this, a marine survival research group from Newfoundland had male and female participants expose their hands to 4 conditions. The first was a control condition of warm and dry hands, which was done by immersing the hand in warm water and then drying them. Next was a wet condition, where there was warm immersion but no drying. The cold condition had the hands in very cold water for 2 minutes and then dried, while the combined cold-wet condition had that same immersion but no drying. The test performed included a point discrimination test for finger sensitivity, a one-handed Purdue pegboard task of putting in as many small metal pegs as possible in 30 seconds, and a knot untying task testing gross hand function. The tactile sensitivity test showed that the 2 cold conditions made the fingers much less sensitive than the 2 warm conditions. When it came to the fine finger dexterity test with the Purdue pegboard, we can see that both the cold and the wet conditions reduced performance compared to the control, and by about the same amount. The 2 factors added up to make the cold and wet conditions worst of all. Let's now look at the knot untying task, where the 2 knots had to be untied using both hands. The same pattern was seen as with the Purdue pegboard, with the time needed to untie the knots higher by about the same amount when the hands were either wet or cold compared to control. Again, the 2 factors added up, and the cold and wet condition was slower again than either by itself. The new and interesting finding in this study is that having wet hands by itself was as bad as having cold hands. Furthermore, having cold and wet hands together added up to further reduce manual function. This knowledge can be used to improve the design of equipment that might be used in these environments, ideally making them easier to hold and requiring less force and dexterity to use. It can also inform changes to work to either accommodate this reduced capacity or to protect workers from getting cold or wet in the first place. Finally, this can aid in modeling accident risk or the odds of survival when accidents do occur. Hopefully this video doesn't leave you chilled and frosty about environmental physiology. I'm Professor Stephen Chung, and I run the Environmental Ergonomics Lab in the Department of Kinesiology at Brock University. We post new videos about different topics in environmental physiology every Wednesday. Thanks for watching. We'll see you next time.